Morning friends, let us recall what we did before. We learned what are sequences. We found out that sequences have a general term. We learned what is an arithmetic sequence. Yes, what is an arithmetic sequence? Arithmetic sequence is a sequence in which the common difference remains constant. And then we derived the formula for the nth term of an arithmetic sequence given by an equal to a plus n minus 1d. So, in an arithmetic sequence, we denote a as the first term and d as the common difference. So, if we want to write down the sequence now, we'll write the first term a, the second term will get a plus d adding the common difference, the third term will be a plus 2d, the fourth term is given by a plus 3d, and so on. Today what we are going to do are terms based on the common difference. So what you can observe over here, the common difference is d. So if I subtract the first term from the second term or the second term from the third term, the common difference remains the same. For example, if I've got arithmetic sequence denoted by a, b, c, d, e, where a, b, c, d, e are succeeding terms of a sequence, then we have b minus a is equal to c minus b is equal to d minus c is equal to e minus d. Why do we have that? B minus a is the difference, c minus b is the difference, d minus c is the difference, e minus d is the difference. Now because the difference remains constant, that is equal, we have these terms equal. So now we'll try out sums based on this common difference. So here we have a sum on the board based on common difference. The sum is if the numbers x plus 3, 2x plus 1 and x minus 7 are in AP, find the value of x. Now it is given the three terms are in an AP. When they are in an AP, the common difference should remain the same or remain equal. How do we find the difference? We find the difference by subtracting the term by the succeeding term. So here we find the difference, common difference, by subtracting x plus 3 from 2x plus 1. So we have 2x plus 1 minus x plus 3. In the same way, the common difference found out by subtracting the second term from the third term should also be equal to the same difference because the difference is constant. Yes. So we get x minus 7 minus 2x plus 1. Now once we reach this step of common difference, then we only simplify it to get the answer. But I hope you have followed what we are supposed to do. Again, when three terms are given in an AP, the common difference between the term remains the same. So the first term, which is subtracted from the second term, or the second term subtracted from the third term, gives us common difference which remains equal. Now we simplify this. So we get 2x plus 1 minus x minus 3. Remember, minus into plus is minus, equal to x minus 7 minus 2x minus 1. 2x minus x gives us x. 1 minus 3 gives us minus 2. X minus 2x gives us minus x. And minus 7 minus 1 gives us minus 8. So now we have, moving minus x on this side, x plus x equal to minus 8 plus 2. So what do we have now? 2x equal to minus 6. So x is equal to minus 6, the multiplication comes in division, equal to minus 3. Hence we get the answer x equal to minus 3. I hope you have followed this sum. This is a sum based on common difference where we had an unknown variable, but we were given that the three terms are in arithmetic progression, and because we know they are in arithmetic progression, the common difference remains the same and the unknown variable can be found out using this method. I hope you have understood. Now we have a similar sum. Find the value of k for which the terms 2k plus 1, 8 and 3k are in AP. The sum is similar to the previous one, and what we do, apply the same technique. So let us begin. We will have 8 minus 2k plus 1 should be equal to 3k minus 8. 8 minus 2k minus 1 equal to 3k minus 8. 8 minus 1 is 7. So 7 minus 2k equal to 3k minus 8. Now we move the k to this side. So we have minus 2k minus 3k equal to minus 8 minus 7. Minus 2 minus 3 gives us minus 5k. Minus 8 minus 7 gives us minus 15. So value of k should be minus 15 upon minus 5, which gives us 3. As the value of k is 3. This sum is similar to the previous sum, and these are a few types of sum based on common differences where 3 terms of an AP are given and we have to find out the unknown term. Okay friends, now here we have a little divert from our normal type of sums. Here we are given arithmetic sequence whose first term is A, but we don't know what the A is. We have no idea what the common difference is, but we know 2 terms of the sequence, the mth term and the nth term. When this is the case, how do we find out the first term? How do we find out the common difference? We'll derive the formula and then we'll go to the shortcut of finding the common difference D. Now since we know the mth term, how do we write the mth term? The mth term is written as A plus m minus 1 d. If you open the bracket, you get A plus md minus d. How do we write the nth term? The nth term is written as A plus n minus 1 d. On expanding, we get A plus nd minus d. Now if we subtract the nth term from the nth term, what do we get? On the left side we get am minus an, and here we get a minus a, which gets cut off, md minus nd, and minus becomes plus, and this gets cut off. So we are left with am minus an and md minus nd. This further simplifies to am minus an, we take out the d common and we get m minus n. So the common difference d is directly found out by writing am minus an upon m minus n. So again, in this sequence we do not know what the first term is, we don't know what the common difference is, but we know the value of the mth term and we know the value of the nth term. Then the common difference can be directly found out by using the formula d is equal to mth term minus nth term upon m minus n, or the reverse, nth term minus nth term upon n minus n. So now we have got a shortcut to find the d when 2 values of a sequence are known. So let us see how to put it in use. So here we have the sum using this formula, the shortcut formula for d. D is equal to am minus an upon m minus n. Now what do we have here? We have given an AP here. This is an AP. It is mentioned it is an AP. We know the second term and we know the sixth term. And we have to find the remaining terms of this sequence. Yes? So can we use this formula directly? Let us see. We have got d is equal to, which is this term? Sixth term. So a6, second term a2 upon 6 minus 2. So d is equal to, what is the sixth term? Minus 22. Second term minus 38 upon 4. 6 minus 2 is 4. This is minus 60 upon 4, which gives us minus 15. So as you see, This sequence is a decreasing sequence. The second term is 38 and the sixth term is minus 22. So the difference is negative because this is a decreasing sequence. So how do we find the terms now? Simple. You will keep on adding the terms to go further or subtracting the terms if you want to go to the left side. So 38 minus 15 is 38 plus 15 gives us 53. So 53 minus 15 gives us 38. 38 plus minus 15, that is minus 15, will give us 23. 23 plus minus 15, that is 23 minus 15, will give us 8. 8 plus minus 15, that is 8 minus 15, will give us minus 7. And minus 7 minus 15 will give us minus 22. So here, with the help of the shortcut formula, we have found out the remaining terms of the sequence. I hope you like this sum. This is a very interesting sum. Can be asked as an MCQ. So you can use this direct formula to find out the terms of the sequence. Here is the second sum based on the same shortcut formula. Yes, this is an AP. We know the first term. We know the fourth term. We apply the same principle. So let's carry on. D is the fourth term minus the first term upon 4 minus 1, which gives us, now let us simplify, 9 2s are 18 plus 1 19, so 19 upon 2 minus 5 upon 4 minus 1, which is 3. This gives us by the LCM 19 minus 2 5s are 10 upon 2 the whole upon 3. This becomes 9 upon 2. And when we take the 3 on the top, we take the reciprocal, we get 1 upon 3. 3 1s are, 3 3s are, and the common difference is 3 upon 2. So D of this sequence is 3 upon 2. Now we will add, because it is positive, we'll add. So to find this term, what we need to do? We need to add 5 plus 3 upon 2. 2 5s are 10, 10 plus 3, 13. So this term is 13 upon 2. Yes, 13 upon 2. To find the next term, we have got 13 upon 2 plus 3 upon 2. 13 plus 3 is 16. 16 upon 2. 2 1s are, 2 8s are. So this term we get 8. And now verify. Adding 8 plus 3 by 2 will give us 9 integer 1 by 2. So again, using the shortcut formula for common difference, we have solved one more sum using the same technique. Sum of the same technique, we have to find the values of A, B and C if A, 10, B, C, 31 are in AP. There are 5 terms given here, A, 10, B, C, 31, which are in an AP. So we have to find values of A, B and C. So what you can see in the arithmetic sequence, we know the second term and we know the fifth term. First, second, third, fourth, fifth. We know the second term and we know the fifth term. So can we find out the D? Yes. We'll find the D by using the formula. We know the fifth term and we know the second term. So below we write m minus n, that is 5 minus 2. What is the fifth term? 31. And the second term is 10. 5 minus 2 is 3. 31 minus 10 is 21. And 21 upon 3 gives us 7. So the common difference is 7. Now it's a positive difference. So we add when we go to the right. But when we go to the left, we subtract. So the first term A is 10 minus 7, which gives us 3. So A is equal to 3. The next term is after 10. Since it is on the right, we add the difference. So B is equal to 10 plus 7 equal to 17. So B is 17. C. We get by adding 7 to the the third term, sorry. So we get 17 plus 7 equal to 24. So this term is 24. And you can see on adding 7 to 24, we get 31. So here we had an AP whose second term and fifth term we were aware of. So we use it to find out this equation. Here we have got a similar type of sum. We are given an AP in which the sixth term is given as 19 and the 17th term given is 41. And we have to find the 40th term. Now we know in the sequence the sixth term is 19, the sixth term is given, and the 17th term is 41. So using the shortcut formula, we can always find out the common difference. So first, let us find out the common difference. So D is equal to the 17th term minus the 6th term. So below we write 17 minus 6. What is the 17th term? 41, and the 6th term is 19, and 17 minus 6 gives us 11. 41 minus 19 is 22. So 22 upon 11 gives us 2. So with the formula, we have found out D is equal to 2. Now can we proceed to find the 40th term? Let's check. The 40th term of the sequence is written as A plus 40 minus 1 D, or A plus 39 D. Okay, we have found the D, but in this sum we do not know what the A is. So first we have to find out the A. How do we find out the A? By using any of these two terms given to us. For example, we are given the sixth term is 19. So sixth term is written as A plus 5D. Since we know the sixth term is 19, we are at 19 equal to A plus 5. And what is the D we got? The D was 2. So we get 19 equal to A plus 5 2s are 10. Moving this side, 19 minus 10 equal to A. So A is equal to 9. So there was a difference in this sum. Because we were told to find the 40th term, we needed to find out the A, the first term of the sequence. In the previous sum, if you remember, we did not need to find out the first term of the sequence, but here to find the 40th term, we should have known the first term, and the first term we can find out by finding D and later on using either of the term of the sequence. I have used the sixth term with the formula. I hope you have understood. Have you followed this? We have found out D by using the shortcut which we got directly, but because we need to know the 40th term which gives the formula by the formula A plus 39D, I need to know the A. But since I did not know the A, I found out the A by the term which was known to us. The sixth term is known as 19, the 17th term is 41, so we can use either of the formula. So we have found the A. Now let us replace the value. So it is 9 plus 39 into 2. 9 plus 39 2s is 78, and 78 plus 9 should give us 87. So the 40th term of this sequence is 87. To find a term of the sequence, we should know A, the first term, and the common difference. The common difference can be found out by the shortcut, but the first term will have to be found out by using either term and the formula. So I hope you have understood this sum. Friends, here I've got a slight variation in the sequence. We have to find a common difference. But what is this sum saying? Inserting m terms between two numbers to result in an AP. So what are we actually doing? Suppose I have got a number, say A, and a number, say B. I want to insert some terms between A and B, but it should result in an AP. So suppose I insert 1, 2, 3, 4, 5, 6 and 7. I am inserting 7 terms between A and B, but it should result in an AP. Okay, 7 terms. In our general terms, I want to put m terms between A and B to result in an AP. Now see this example. When I put 7 terms between A and B, which term is B now? Check. I put 1, 2, 3, 4, 5, 6, 7. So when I put 7 terms between A and B, this is the first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term and ninth term. Generally, B, the last number, becomes the m plus 2th term. Are you following this? When I put n terms, here I put 7. So when I put 7 terms in between, what is 7 plus 2? 9. So B becomes the 9th term. Check. First, second, third, fourth, fifth, sixth, seventh, eighth and 9. So B has become the 9th term. And in general, when we put m terms between A and B, B becomes m plus 2th term. Okay. Now using the formula, an equal to a plus n minus 1 t. When we use this formula, what I put in the place of nth now? Because I want to find the m plus 2th term. So I will take a m plus 2th term. What I have done? I have put m plus 2 in the place of n. This is the nth term. We can show any general term. So I am taking m plus 2th term. Will give me a plus, and what I should write in the place of n? M plus 2. So m plus 2 minus 1 t. Now which is the m plus 2th term? M plus 2th term is b. So b is equal to a plus m. What is 2 minus 1? Is 1. So I get m plus 1 t. Now I rearrange this formula. I take a on the left side. So I get b minus a equal to m plus 1 d. And when I rearrange m plus 1, I get b minus a upon m plus 1 equal to d. This is another variation of the formula, but this is for a different reason. What is this d? This is the difference when we are going to insert m terms between two numbers. So when the two numbers are given to you, you will subtract those two numbers, divided by the terms you insert m plus 1, and you will get the common difference d. Now we'll try one sum using this formula, so see if you understood the formula very well. Okay, maybe an example will help you understand better. We have a sum based on the previous formula. Insert 6 terms between 12 and 33 such that the resultant sequence is an AP. So what have we got? We have got 12 and we have got 33, 12 and 33, and we have to 1, 2, 3, 4, 5, 6. We have to insert 6 terms between 12 and 33 to result in an AP. So which formula we have done for this type of sum? D is equal to b minus a upon m plus 1. What is our b? 33. What is our a? 12. And what is the m here? 6, because we have to include 6 terms. So 6 plus 1 makes it 7. 33 minus 12 gives us 21. 21 upon 7 gives us 3. So D is equal to 3. This is the difference we need to find by this formula when we insert terms between two numbers. So now we have D equal to 3. So let us carry on. 12 plus 3 would give us 15. 15 plus 3 will give us 18. 18 plus 3 will give us 21. 21 plus 3 will give us 24. 24 plus 3 will give us 27. And 27 plus 3 will give us 30. And 30 plus 3 gives us 33. So this is the different formula we use when we have to insert n terms between two given numbers to result in an AP. Again, we have to insert 6 terms between 12 and 33. That is, m is 6. We know b, we know a, we know m. Using the formula, we find out the difference. And then using the difference formula, we find out the AP. I hope this sum was simple and you liked it. Examples and exercises given in your module. And we have solved so many examples. I hope that you understood and you will be able to solve the sums given to you in your exercise. This is one example that we'll take so you can understand one more type of sum, and then you can move on to your exercises. In case you got any doubt, then you can always contact us. We'll be there to guide you. But let us go on with this sum now. We are given m times the nth term of an AP is equal to n times the nth term, and we have to show the m plus nth term of that AP is 0. Let us consider the AP whose first term is A and common difference is D, and we are given m times the mth term is equal to nth times the nth term, and we have to show the m plus nth term of the AP is 0. We'll proceed using the same formula. M, how is the mth term written? By the general formula A plus m minus 1 D equal to n into, what is the nth term? A plus n minus 1 D. Let us simplify. We have A plus m into D md minus 1 into D minus D equal to n A plus n into D and D minus 1 into D minus D. Simplifying further, open the bracket, A into n am plus m into md m square D minus m into D md equal to A into n an plus n into nd is n square D, n into minus D minus nd. Now we'll rearrange the terms on this side. So we have am minus an plus m square D minus n square D minus md, and on this side plus nd equal to 0. Now taking out terms common, from this two we have got a common, we are left with m minus n, plus from these two terms we get d common, so we have m square minus n square, and here we have a minus d common, resulting in m minus n equal to 0. Further, we'll simplify this, so m minus n plus d. Now m square minus n square is m minus n into m plus n, and we have got minus d, m minus n equal to 0. So till here we have done the simplification. Now what you can see, we have got this term m minus n common in everything. So we have m minus n into bracket a plus, we take out this common, so this remains d into m plus n, and here we take out m minus n common, so we have got minus d equal to 0. Now taking m by n into the denominator will give us the same thing. We'll take it into the denominator. So what is left here? We have got a plus, from this two I take out the d common, so I get m plus n minus 1 equal to 0 upon m minus n. This results in, what does this result in? A plus m plus n minus 1 d equal to 0. What do you figure? Now compare, which is this term? Look at this. Are we not writing this term as a and m plus nth term? So how is the m plus n term written? As a plus m plus n minus 1 d equal to 0, which gives us a plus m plus nth term is equal to 0. So we have proved that when the m times the n term of an AP is equal to n times the nth term, then the m plus nth term of that AP is 0. So we have done quite a few sums here for your help and explain it to you. We have provided you exercises in the material which we have given to you. There are different kind of sum. There are simple sums of finding the terms, common differences and so on, and even prove that sums. Now I would like you to work on that exercise, and if you got any doubts, you can call us anytime for the help that you need. Okay, thank you. We'll finish the module here for the week.